Hi everybody, I'm Paul, and today I'm presenting my Redis Cascades renderer. In this video, I want to present an approach that I've developed that will be a focal point of my master's thesis. I call this approach cached cascades. First, let's discuss the typical cascades case. In the typical, something that you would read about in the paper case, we are using the ping pong method. So we are using two render targets that render from A to B, then from B to A, from A to B, etc., etc. A couple times to render basically couple render targets. This way we render 6 render targets, where each subsequent render target can draw from the previous one. This is used during the merging process, right? And this ensures lowered memory throughput. Generally, lower memory consumption. Since we only have 2 render targets, there is less data that must fit in the GPU's cache memory, which makes for a quite quick algorithm. In my approach, I, unfortunately, resign from keeping this cache friendly. In my approach, I'm using caching, and I'm actually rendering each cascade to its distinct render target. And the amount of render targets is fixed. So this will introduce certain drawbacks. For example, when you're using render cascades, when you're using the cached cascades version, you wouldn't be able to go from rendering a really small space to really huge lead space, because that would require rendering more cascades and allocating render targets on the fly. While you can do that, that is probably quite expensive. Now, in my approach, you can render those higher cascades sparsely, and I mean sparsely in the temporal dimension. So let's maybe draw some exemplary points here. Let's increase it slightly. Let's draw some pink, let's draw some purple, let's draw some black, let's increase maybe the size here. And as you can see, what I want you to focus on is how smooth is the dynamic shadow for each of those points, right? So let's maybe increase the speed. As you can see, do you see it in the video? Yes, you do. The shadows are quite smooth, right? So what I'm worried about is that when I cache the higher level cascades, the shadows and the presentation is going to be much less smoother, or even worse, there's going to be some smudging. So let's switch to cached cascades version. As you can see, we are rendering 6 cascades, and we can choose the frequency. So right now it's set on 1, so every single frame, every cascade is being rendered. And so this is a normal case. As you can see, the performance is pretty much the same as in case of the normal Redis Cascades preset. So it means that the cache isn't affected that much. I'll be honest with you, I'm using the unsigned byte textures for that. So the data for each pixel is represented by 32 bits of data. So that's probably really important because it lowers the size of the texture by 75%. Yeah, so let's now start rendering each cascade at slightly different intervals. So let's maybe render the lowest cascade at let's say 50, right? And what we can see is that the performance jumped to around 200. We had 150, right? 150, right? And now it's 200. And the loss in quality, I personally don't see any loss in quality. Maybe it's I just don't see this. So I would say that that's something cool. Next, let's render the 4th cascade. I mean 5th really when you look at it, at 25. And again, there's an increase in performance by 100 FPS. That's a lot of FPS, okay? And again, there is maybe a negligible decrease in fidelity. You can see that the shadows are kind of jumping, right? But especially for the dynamic lighting, for example, the fire, it's so chaotic that it's kind of hard to tell whether the shadows are really okay or not. Maybe a good idea would be to introduce a moving object that generates really predictable shadow patterns. That's something I might do actually, because it would ensure that I could really well diagnose whether the shadows are accurate or not. Let's start decreasing the frequency further. Let's decrease the frequency of the third cascade to, let's say, 13, right? So 12 and a half, let's round up. And again, performance jumped by around 60 FPS. And again, the decrease in performance, the decrease in fidelity, that you start to see this, right? The shadow starts kind of flickering, but again, it's not that visible. What I've noticed, draw canvas, yes, so a drawing canvas, right? Let's draw some subtle color here. What I've noticed is that the propagation of the cascade is slower. As you can see, there is this halo at the very beginning. Halo at the very beginning is from the low-level cascades, right? Because they're really close to the point you're drawing. And as you can see, when you're drawing, it starts really from the point that we are drawing and expands. I hope it's visible on the screen. So let's erase it, and I will show you one more thing. What is really interesting is that when you lower the cascades of the lowest levels, what you will notice is that although the performance increases, the quality of the image becomes really stuttered. So let's, for example, decrease the third cascade here, right? As you can see, this becomes kind of steppy, right? It becomes kind of step-like. Especially when you compare it to Radiance Cascades preset, it becomes kind of like jumpy. Okay, again, performance is increased. And when you increase even further for like lower cascades, it becomes a mess, right? So especially like the lowest cascade, it's really messy. What saves us here is the fact that we are rendering at 500 FPS, so it's not that visible. But if it was more visible, for example at high resolution, or maybe there is some more intense logic in the background where rendering is not only thing that we are doing, rendering lower cascades at super lower frequencies just becomes not viable. But still, I think we can get away with just rendering two last cascades at lower frequencies because the performance gain is just phenomenal, right? It's around 100% of the performance gain. So I would say that's just a net positive. Yeah, so that's what I wanted to show you. That's how I deal with it, and I think it's a really cool way to optimize this method. Obviously, there is probably some edge cases that I still need to explore. Probably more dynamic scenes would really test this method and would see if this is even viable. But yeah, I think that this is pretty cool. And yeah, I want to present this. Goodbye.